How governments decide on space exploration funding. Governments face complex choices when funding space exploration. Decisions are influenced by scientific goals, such as advancing knowledge and developing new technologies, political ambitions, including demonstrating national power and prestige, economic considerations, like fostering new industries and job creation, and public interest, which can drive support for missions that capture the public imagination. For example, a mission to Mars might be prioritized for its scientific discoveries, economic impact, and national prestige. These factors shape the direction of space programs and influence mission priorities. Scientific and technological benefits. Many countries fund space exploration to advance scientific understanding and develop new technologies. Missions that promise breakthroughs in astrophysics, planetary science, or climate monitoring are often prioritized for their potential contributions to knowledge and practical applications on Earth. For instance, studying other planets provides insights into the origins of the solar system and helps us understand our own planet. Space missions often lead to innovations in telecommunications, medicine, and materials science. The discovery of water on Mars by NASA's Curiosity rover illustrates the tangible scientific breakthroughs that such investments can yield. This discovery has significant implications, such as the potential for human colonization and the possibility of past microbial life on Mars. National prestige and soft power. Space exploration is also a matter of national pride. Achievements in space elevate a nation's international status and demonstrate technological prowess. During the Cold War, space accomplishments symbolized political superiority, exemplified by milestones like the Apollo 11 moon landing. Today, countries like India and China invest heavily in space to assert their position on the global stage. For example, India's Chandrayaan-3 mission successfully landed near the Moon's south pole, while China's Tianwen-1 mission explored Mars. Successful missions foster national pride and enhance a country's image as a leader in science and technology, helping to build alliances and inspire future generations to pursue STEM careers. Economic and industrial growth. Governments may fund space programs to boost their economies. Investments in space lead to advances in aerospace technology, new industries, and job creation. Public-private partnerships with companies like SpaceX or Blue Origin distribute costs while encouraging commercial growth. For example, NASA's collaboration with SpaceX for Crew Dragon missions reduced costs while achieving reliable crewed launches, showcasing the benefits of shared resources. The commercial space industry, including satellite services and space tourism, has the potential to generate significant economic returns and contribute to long-term growth. For example, SpaceX's Starlink project has demonstrated the potential for satellite services to create substantial revenue and expand global internet access. Strategic and security concerns. Space is increasingly viewed as a domain of strategic importance. Governments prioritize funding space initiatives that enhance national security, such as satellite-based communications and surveillance. Satellites play a critical role in defense systems, providing real-time intelligence and secure communication. Maintaining a presence in space ensures a country can keep up with rivals such as the United States, China, and Russia, and protect its assets. Countries are also investing in space situational awareness and anti-satellite capabilities to maintain a strategic edge. The militarization of space, while controversial due to concerns about escalating tensions and space becoming a battleground, underscores the importance of maintaining a presence in this critical domain. Public interest and advocacy. Public interest and advocacy can also sway funding priorities. Influential voices, from scientists to the general public, can pressure governments to invest in space exploration. Programs that capture public imagination, like missions to Mars or searching for extraterrestrial life, often receive greater funding. For example, NASA's Apollo program benefited from strong public enthusiasm, which translated into sustained funding during the 1960s. High-profile missions like the Mars rovers generate excitement and inspire curiosity, helping build support for continued investment in space. Conclusion. Balancing these factors, governments decide what will provide the greatest overall benefit, considering scientific value, economic return, national prestige, security, and public interest. The future of space exploration depends on technological capability and the priorities set by those in power. International collaboration, public-private partnerships, and innovative funding approaches will be key to unlocking the potential of space exploration. Space mining laws. Who owns the resources of space? As humanity extends its reach beyond Earth, questions about the ownership and use of space resources have moved from the realm of science fiction to pressing legal and ethical debates. From mining asteroids for precious metals to extracting water from the moon, the governance of space resources is shaping up to be one of the most significant challenges of the 21st century. The international framework at the heart of space law is the 1967 Outer Space Treaty, OST, signed by over 100 countries. The treaty establishes several guiding principles. Non-appropriation. Outer space, including the moon and other celestial bodies, cannot be claimed by any nation through sovereignty or any other means. Freedom of exploration. All states are free to explore and use outer space. Benefit of all humanity. Space activities must be carried out for the benefit of all countries and humankind. While the OST provides a broad framework, it leaves significant ambiguities regarding the extraction and ownership of space resources. For example, while the treaty prohibits nations from claiming sovereignty over celestial bodies, it does not clearly address whether private companies can extract and own resources from them. The 1979 Moon Agreement sought to fill this gap by declaring the Moon's resources the common heritage of mankind, meaning that these resources should be managed collectively and used for the benefit of all humanity. It proposed an international regime to oversee resource exploitation. However, this agreement has been ratified by only a handful of countries and lacks support from major spacefaring nations like the United States, Russia, and China, largely because they viewed its provisions as overly restrictive and limiting to national and private enterprise interests. National legislation, a patchwork approach. In the absence of comprehensive international laws, several countries have enacted their own legislation to regulate space mining. United States. The U.S. Commercial Space Launch Competitiveness Act of 2015 allows U.S. citizens to explore, extract, and own space resources. While the U.S. does not claim sovereignty over celestial bodies, this law asserts the rights of private entities to commercially utilize resources they extract. Luxembourg. In 2017, Luxembourg passed laws permitting companies to own and sell space resources. The country aims to position itself as a hub for space mining enterprises. These national laws reflect a growing interest in commercial space activities, but have also raised concerns about their alignment with international treaties. For example, there are concerns that unilateral national laws might lead to conflicting claims over the same resources, creating legal and diplomatic disputes. Critics argue that unilateral approaches risk creating conflicts over resource claims and undermine the spirit of international cooperation. Emerging challenges and developments. As nations and private companies gear up for lunar missions and asteroid mining, the lack of a unified legal framework poses significant challenges. Resource conflicts. Without clear international regulations, disputes over resource claims could escalate into geopolitical tensions. Equitable access. Developing countries fear being left out of space resource opportunities as wealthier nations and corporations dominate the field. Environmental impacts. The long-term consequences of resource extraction on celestial bodies remain largely unexplored. The Artemis Accords, led by the United States, represent an attempt to establish norms for responsible and peaceful space exploration, including resource utilization, and to prevent potential conflicts. As of now, over 20 countries, including Japan, Canada, the United Kingdom, and several European nations, have joined the Accords, demonstrating a significant level of international support. While these bilateral agreements promote transparency and cooperation, some nations view them with skepticism, fearing they favor US interests. The road ahead. The prospect of space mining offers exciting opportunities for scientific advancement and economic growth, such as mining rare earth metals or extracting water from the moon to use as fuel for deep space missions. These resources could significantly impact industries on Earth, providing new sources of rare materials for electronics and renewable energy technologies. However, it also demands a careful balancing of interests to ensure that space resources are used peacefully and for the benefit of all humanity. To achieve this, the international community, led by bodies such as the United Nations, must work towards a comprehensive and inclusive legal framework. Such an agreement should address key issues like resource ownership, environmental stewardship, and equitable access, ensuring that the final frontier remains a domain of shared opportunity rather than conflict. As we stand on the brink of a new era in space exploration, the choices we make today will shape the future of humanity in space. Will we embrace collaboration and equity, or allow competition and disparity to define our interstellar ambitions? The Artemis Accords, setting the stage for Moon and Mars exploration. As humanity sets its sights on returning to the Moon and venturing onward to Mars, international collaboration is more important than ever. Pooling resources, sharing expertise, and avoiding duplication of efforts are critical to making these ambitious goals achievable. For example, the International Space Station, ISS, is a testament to successful international collaboration, where multiple nations have worked together to achieve continuous human presence in space and conduct valuable scientific research. Enter the Artemis Accords, a set of guidelines designed to promote peaceful, cooperative and transparent exploration of space. Introduced by NASA in October 2020, these agreements have been signed by 48 countries and counting, each committed to upholding a shared vision for sustainable space exploration, guiding principles for a new era of space exploration. The Artemis Accords are more than just an agreement. They are a comprehensive framework, featuring specific principles such as transparency, peaceful use, and interoperability. These accords set themselves apart from previous space agreements and have garnered support from 48 participating countries. They serve as a blueprint for how we, as a global community, can safely explore and utilize space. Here are the key principles that make these accords vital to the future of space exploration. Peaceful exploration. All activities conducted under the Artemis Accords are for peaceful purposes, ensuring that space remains a domain of exploration and collaboration rather than conflict. Transparency. Trust is the foundation of any successful partnership, and the Accords emphasize transparency in space policies and plans, promoting open communication and cooperation between nations. Interoperability. The goal is to create systems that work seamlessly with one another, enhancing collaboration among different space agencies and reducing risks during joint missions. Emergency assistance. Space is unforgiving, and help is essential. The Artemis Accords ensure that astronauts in distress can receive assistance, reinforcing the commitment to safety for all spacefarers. Registration of space objects. To maintain transparency and avoid conflicts, signatories agree to register their space objects, making it easier to track activities and ensure accountability. Release of scientific data. Sharing is caring, especially in space exploration. The Artemis Accords encourage the public release of scientific data to benefit the entire global community, helping to advance our collective understanding of the universe. For example, data sharing from the Apollo missions and the Hubble Space Telescope has led to significant scientific breakthroughs and inspired generations of researchers. Preservation of outer space. Heritage. Humanity's history in space is precious. The Accords call for the protection of historically significant sites and artifacts, such as the Apollo landing sites, ensuring that our space heritage is preserved for future generations. Space resources. Space is full of potential resources, from water ice on the moon to minerals on asteroids. The Artemis Accords affirm that resource extraction should be conducted safely, sustainably, and in line with international law, without claims of national ownership. Deconfliction of activities. With multiple nations operating in space, it is crucial to prevent interference. The Accords establish safety zones around operations to ensure activities do not overlap in harmful ways. These safety zones are defined areas around a mission site where coordination is required to prevent interference with ongoing activities. Orbital debris mitigation. Space junk is a growing problem. The Artemis Accords underscore the importance of minimizing space debris to keep the space environment safe for current and future missions. Why the Artemis Accords matter? The Artemis Accords represent a landmark framework toward ensuring that space exploration remains a cooperative endeavor. By adhering to these principles, nations are laying the groundwork for peaceful exploration, scientific advancement, and the responsible use of space resources. This framework is crucial for building trust among nations, sharing knowledge, and making sure that the wonders of space exploration are accessible to all of humanity. As we prepare to return to the moon, establish a sustainable presence there, and eventually set foot on Mars, the Artemis Accords will guide our way, reminding us that the final frontier is not a place for competition, but for collaboration and discovery. Looking to the future, the Artemis Accords are just the beginning. Upcoming missions, such as NASA's Artemis III, which aims to land astronauts on the lunar surface, and collaborative projects focused on developing lunar bases, will build on the principles established by the Accords. Additionally, advancements in technologies like in situ resource utilization, ISRU, and potential future international partnerships for Mars exploration will further enhance collaboration and push the boundaries of what we can achieve together. As more countries join and as missions to the Moon and Mars progress, the Accords will play a vital role in shaping how we explore space together. If humanity is to take its next great leap, it will do so hand in hand, following the principles that ensure our ventures are safe, sustainable, and for the benefit of all.
In 1967, during the Cold War and the escalating space race, the Outer Space Treaty was adopted to address the growing concerns about the militarization of space and the escalating competition between superpowers. The urgency of establishing rules for space activities was driven by fears that space could become another theater of conflict, particularly after early Cold War developments such as the launch of Sputnik by the Soviet Union in 1957 and subsequent missile tests, which demonstrated the potential for space-based military capabilities. Officially known as the Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including the Moon and other celestial bodies, it established the foundation of modern space law. This treaty ensures that space remains a domain for peaceful exploration and the benefit of all humankind. Let's examine its key provisions and their relevance today. Key principles of the Outer Space Treaty. 1. Peaceful use of space. The treaty declares that outer space, including the moon and other celestial bodies, shall be used exclusively for peaceful purposes. It prohibits placing nuclear weapons or any weapons of mass destruction in orbit or on celestial bodies, preventing space from becoming another battleground. This principle paved the way for international cooperation in satellite communications, space research, and planetary exploration, exemplified by missions such as the Apollo-Soyuz mission, which marked the first joint U.S.-Soviet spaceflight and symbolized détente during the Cold War, and the International Space Station, ISS, a long-term project involving multiple countries working together for peaceful space exploration. 2. Non-appropriation principle. The treaty states that no country can claim sovereignty over outer space or any celestial body. Outer space is the common heritage of all humankind, preventing any nation from claiming exclusive rights to the moon or other planets. This principle aligns with other international agreements, such as the Antarctic Treaty, which similarly designates Antarctica as a region dedicated to peace and scientific research. This fosters shared responsibility and encourages international collaboration on missions and discoveries. 3. No military activities on celestial bodies. The treaty prohibits military bases, installations, or weapons testing on celestial bodies. All space activities are intended for peaceful purposes, ensuring a stable environment for exploration and scientific study. This principle remains relevant as countries develop advanced military technologies that could operate in space. 4. Responsibility for national activities. States are responsible for the activities of both their governmental and non-governmental entities in outer space. This means countries must regulate private companies operating in space to ensure compliance with treaty principles. As private companies push the boundaries of space exploration, governments must balance innovation with international peace and accountability. This can be achieved through public-private partnerships, fostering collaboration while ensuring compliance with international norms. Additionally, developing international regulatory frameworks can help create consistent guidelines that support innovation without compromising safety and peaceful use. A recent example of a successful public-private partnership is NASA's collaboration with SpaceX through the Commercial Crew Program, which enabled SpaceX to develop the Crew Dragon spacecraft, successfully ferrying astronauts to the ISS since 2020. 5. Avoiding harmful contamination. The treaty commits to avoiding harmful contamination of space and celestial bodies. This includes preventing contamination of celestial bodies by Earth organisms and protecting Earth from extraterrestrial matter. This principle ensures that space remains a pristine environment for scientific study and that Earth is safeguarded from unintended risks. As missions to Mars and other celestial bodies increase, maintaining the integrity of these environments is crucial for scientific research and planetary protection. 6. Assistance and cooperation. Astronauts are regarded as envoys of humankind, and the treaty emphasizes cooperation and mutual assistance. States are required to help astronauts in distress and share information about space activities, fostering collaboration. This principle has been crucial for international partnerships, such as the International Space Station, ISS, where astronauts from different nations work together on scientific research and technology development. Modern challenges to the treaty. Private space exploration. With companies like SpaceX and Blue Origin becoming major players, questions arise about their obligations under the treaty. Governments must ensure private entities respect principles of peaceful use and non-appropriation. Resource extraction. The treaty forbids appropriation of celestial bodies, but space mining raises legal and ethical questions about ownership and profit sharing. Developing an international framework will be essential to ensure resource extraction benefits all of humanity. Space debris. Space debris is a growing issue with thousands of satellites in orbit. The treaty encourages avoiding harmful contamination, but lacks a framework to address the debris problem. New agreements and technologies for debris removal are needed to mitigate risks, such as active debris removal missions using robotic arms or nets, and international cleanup programs like the European Space Agency's Clear Space One initiative. Looking ahead. The Outer Space Treaty laid the foundation for peaceful and cooperative space exploration, but it needs updating to reflect modern space activities. With goals like colonizing Mars, establishing lunar bases, and mining asteroids, new agreements are needed to address current challenges. Space belongs to all of us, and keeping it peaceful requires international collaboration and forward-thinking policies such as the Artemis Accords, which establish guidelines for responsible lunar exploration and cooperation. The treaty provided the foundation, but we must adapt it to meet future challenges and ensure that space exploration benefits all of humanity.
Once a concept of science fiction, the Space Force is now a reality as nations expand their military presence beyond Earth. The creation of the United States Space Force in 2019, with responsibilities such as protecting satellites, deterring space-based threats, and ensuring freedom of operations in space, has brought to light critical questions about the future of space exploration and its potential militarization. Is this the dawn of a new era of protecting satellite infrastructure? Or are we laying the groundwork for conflicts beyond our planet? Why a Space Force? The primary motivation for creating a Space Force lies in the growing dependence on space-based assets. Modern military, communication, and navigation systems all rely heavily on satellites. The increasing risks posed by anti-satellite, ASAT weapons, and cyber threats from nations like Russia and China have made the militarization of space a priority. The Space Force aims to protect and maintain critical space infrastructure, such as GPS satellites, ensuring it stays operational during times of conflict. The legal framework, an obstacle or outdated? The militarization of space has always been a touchy subject, largely due to the Outer Space Treaty of 1967, which designates space as a global commons. This treaty prohibits the placement of nuclear weapons or other weapons of mass destruction in space. However, the treaty doesn't explicitly address non-WMD military activity, creating grey areas that nations can exploit. The recent drive towards military space capability raises concerns that this legal framework is either outdated or insufficient to prevent an arms race in space, particularly because it does not address modern military activities like satellite weaponization or the deployment of non-nuclear military technology. Defensive posturing or aggressive expansion? Supporters of the Space Force argue that it is a defensive measure aimed at protecting satellite infrastructure and ensuring continued access to and peaceful use of space. For example, in 2007, China conducted an anti-satellite missile test that destroyed one of its own weather satellites, demonstrating the vulnerability of satellite infrastructure and highlighting the need for defensive measures. Supporters contend that much of the world's military communications depend on space, making the capability to defend those assets crucial. In this view, the Space Force is akin to the Navy patrolling vital sea routes. Critics, however, worry that the establishment of a Space Force could be the beginning of an arms race in space. By treating space as a military domain, they argue, it encourages other nations to do the same, leading to a cycle of escalation. This raises fears of Kessler syndrome, where destroyed satellites create debris fields that render space inaccessible, potentially causing a cascading effect of collisions that could make certain orbits unusable, endangering peaceful scientific and commercial activities. The final frontier or the next battlefield? The prospect of space militarization isn't limited to satellites. Concepts such as space-to-ground weaponry, which involves weapons launched from space to targets on the ground, or the deployment of kinetic energy weapons, which use the force of impact from high-speed projectiles rather than explosives, are no longer relegated to science fiction. Furthermore, as private companies like SpaceX and Blue Origin lower the cost of accessing space, the number of active satellites and the potential for conflicts only increase. Countries might soon see military bases on the Moon or strategic control over high-value Lagrange points, which are positions in space where the gravitational forces between celestial bodies create a stable environment, making them ideal for placing satellites or space stations. As we push deeper into the solar system, questions arise as to how we can prevent conflict over resources or territory on the Moon, Mars, or even asteroids. The future, international cooperation or competition? A key element to avoiding the militarization of space might lie in international cooperation. Joint missions, like the International Space Station, which involves countries such as the United States, Russia, Japan, Canada, and members of the European Space Agency are positive examples of collaboration beyond borders. However, as more countries develop independent space programs, such as China's recent lunar missions, the balance between cooperation and competition will be crucial in determining if space remains a place of peace and exploration, or turns into a new domain for military conquest. Conclusion. The formation of a Space Force raises vital questions about the future of space. Is the Space Force a necessary step to ensure security in an increasingly satellite-reliant world, or does it risk setting a dangerous precedent? As we move further into this new era, the choices we make now about the use of space will determine whether it remains a peaceful frontier or becomes yet another battleground. What do you think? Is the Space Force a necessary evolution of military strategy? Or are we opening Pandora's box by militarizing space? Share your thoughts in the comments below.
The future of humanity's expansion into space is no longer just a government endeavor. It's a growing partnership between established space agencies like NASA and ambitious private companies. As both strive to explore new frontiers, it's clear that collaboration will play a key role in humanity's journey into the cosmos, with each contributing uniquely to our shared future among the stars. NASA's role in space exploration. For decades, NASA has been the beacon of human space exploration. From the Apollo missions that landed astronauts on the moon to the ongoing Artemis program, NASA has continuously pushed the boundaries of what's possible in space. The Artemis program, which aims to return humans to the moon and establish a sustainable presence there, is just one example of NASA's commitment to deep space exploration. NASA's focus remains on missions that extend our reach beyond Earth's orbit. By leading missions to the Moon, Mars, and beyond, NASA sets the stage for what's next for humanity, focusing on scientific research and the development of technologies that will support long-duration space missions. NASA's expertise in navigating the vast unknown makes it an invaluable leader in the journey to explore our solar system, as demonstrated by missions like the Mars rover program and the Voyager probes, which have provided groundbreaking insights into our planetary neighbors and beyond. This expertise is not just limited to missions, but also includes breakthroughs in technology, such as advancements in propulsion systems, radiation protection, and space habitats, which are essential for long-term human survival in deep space. NASA's role also involves inspiring the next generation of scientists, engineers, and explorers. Through initiatives like the Mars rover program, Hubble Space Telescope, and the James Webb Space Telescope, NASA continues to expand our understanding of the universe. The agency's efforts in education and public outreach play a critical role in fostering interest in STEM fields, ensuring that future generations are equipped to continue the journey of space exploration. Private companies making their mark. Enter the private space companies, innovative, risk-taking, and commercially driven players like SpaceX, Blue Origin, and Sierra Space. SpaceX, led by Elon Musk, is a front-runner, with its reusable Falcon 9 rockets already revolutionizing how we reach space by significantly reducing costs and increasing the frequency of missions. The ambitious Starship project aims to make human missions to Mars a reality, making interplanetary travel less like a dream and more like an imminent possibility. SpaceX's vision extends beyond just reaching Mars. It aims to create a self-sustaining colony, ensuring the long-term survival of humanity as a multi-planetary species. Blue Origin, founded by Jeff Bezos, is also breaking new ground with plans to develop the Orbital Reef, a mixed-use space station that promises a future where businesses, researchers, and even tourists could have a place in orbit. Sierra Space, in collaboration with Blue Origin, is part of this project, aiming to make space accessible for both work and play by the year 2027. This vision includes not only scientific research, but also commercial opportunities that could make space an extension of the global economy. with industries such as manufacturing, tourism, and even entertainment finding a foothold in orbit. These companies have injected fresh energy into the space industry, focusing on cost efficiency, reusability, and a vision of making space travel attainable for a broader audience. For example, the SpaceX Falcon 9's reusability has led to a significant reduction in launch costs, enabling more frequent missions and expanding access to space for a wider range of customers, including government and commercial entities. They operate with a startup mentality, rapid iteration, calculated risk-taking, and pushing innovation, traits that complement NASA's steady, calculated approach. The innovation brought by these companies is evident in the development of reusable rockets, which has dramatically reduced the cost of spaceflight, making it more feasible to conduct frequent missions and open space to a wider range of participants. Private companies are also exploring ways to make life in space sustainable. For instance, SpaceX's Starship is designed to carry large amounts of cargo and crew, providing the infrastructure needed for building bases on the Moon and Mars. Meanwhile, Blue Origin's focus on reusable launch systems and sustainable technologies aims to create a future where millions of people can live and work in space. The ambition of these private companies is not just about exploration, but also about creating the means for human settlement beyond Earth. Collaboration, not competition. While it might seem like a rivalry, the relationship between NASA and private space companies is far more collaborative than competitive. NASA relies on companies like SpaceX and Boeing to provide transport for astronauts and cargo to the International Space Station, ISS, under the Commercial Crew Program. This partnership helps NASA focus on more ambitious goals, such as Mars missions and deep space exploration, while private companies streamline lower orbit operations. Further collaborations, such as NASA's Commercial LEO Destinations program, aim to develop new commercial space stations that will eventually replace the ISS, ensuring that humanity retains a continuous presence in low Earth orbit. By working together, both NASA and private enterprises are enabling a sustainable human expansion into space. These partnerships are a testament to the idea that the future of space exploration is too vast for any one entity to tackle alone. By pooling resources, knowledge, and expertise, NASA and private companies are creating a robust ecosystem that supports both governmental and commercial aspirations in space. NASA has also benefited from the innovation and speed of private companies, which have driven down costs and introduced new technologies at a rapid pace. The Commercial Lunar Payload Services (CLPS) initiative is another example of NASA's collaborative approach, where private companies are contracted to deliver science and technology payloads to the Moon. This approach not only accelerates the timeline for lunar exploration, but also encourages the growth of the commercial space sector, fostering a competitive environment that benefits everyone involved. The future of space exploration. Who will ultimately lead humanity's expansion into space? The answer lies in the strength of collaboration. NASA's deep space expertise and scientific mission drive, combined with the innovation, speed, and risk-taking spirit of private companies, are what will propel us forward. The public largely recognizes this as well, with surveys showing broad support for NASA's role alongside private companies in making space accessible. This partnership between government agencies and private firms marks the next great leap for humanity. It's not about one entity leading over the other. It's about creating a shared vision of a spacefaring future. Together, they are building the infrastructure, technology, and momentum needed to make the dream of exploring and even living beyond Earth a reality. The vision is not limited to exploration. It encompasses the possibility of humans living and thriving on other worlds, transforming space into a domain where humanity can expand, innovate, and flourish. In the coming decades, we can expect to see more milestones achieved through this collaboration. Whether it's the first human landing on Mars, the establishment of permanent lunar bases, or the development of thriving commercial space stations. The expansion of humanity into space will likely involve a diverse array of participants, from government agencies and private companies to international partners and even civilians. International collaboration will bring together the best minds and resources from around the world, fostering innovation and ensuring that space exploration benefits all of humanity. Civilian involvement, through initiatives like space tourism and citizen science, will also play a key role in making space more accessible and inspiring a new generation of explorers. As the boundaries of space continue to expand, so too does the potential for discovery, growth, and the realization of dreams that once seemed impossible. The journey into space is no longer a solitary pursuit. It is a collective endeavor that requires the best of both worlds, the visionary drive of private enterprise and the deep-rooted expertise of governmental space agencies. Together, NASA and private companies are creating the pathways that will lead us to the stars, ensuring that humanity's future is not confined to Earth, but is instead as boundless as the universe itself.